All right, folks, I want to show you how to work through some of these series circuit problems. So let's take a look at a very simple example right here. And we all know, the one equation that has to do with Ohm's law more than anything else. Voltage is equal to current times resistance. That is the most important circuit's equation. But we also have to know a little bit more about what's going on with this circuit. And so with a series circuit where we have our components of the circuit, for example, R1 and R2, connected right after each other with nothing else in between. And so if we think about what's happening to like electrons that are flowing through this circuit, we have a power source. In this case, it's a 90-volt battery. It's pumping electrons through the circuit. And so we think about electrons going from positive to negative. So my current is going through R1. And as it goes around the circuit, it's got nowhere else to go except back through R2, back to the negative terminal of the battery, and get pumped around again. And so when we think about this, we think about the current applied to R1 has got to be exactly the same as the current going through R2. There's nowhere else for those poor little electrons to go. And so when we're talking about a series circuit, we can kind of summarize this by saying that the current through the voltage source, in this case with R1 and R2, is going to be the same as the current going through resistor 2, and is going to be the same as the current going through resistor 1. And so I'm going to say the current through the voltage source is the same as the current through 2, the same as the current through 1. It's all the same current. Now, with a series circuit, what we're going to have is different voltage drops across R1 and R2. And so, obviously, R2 is twice as big as R1. It's going to resist more current, the same current as R1. It's going to resist that more, which is going to cause an increase in voltage according to Ohm's law. If R is twice as big and I stays the same, voltage has to be twice as big. And so by what's called conservation of energy, if you take in physics, the voltage of the power source in a series circuit is going to be the sum of the voltages of the individual elements. So let me call V1 the voltage across R1, and it's going to be plus V2, which is the voltage across R2. Because Ohm's law tells me if that I is the same, the voltages for R1 and R2 have to be different. So let's look at some of the math and actually solve for some of these problems. Now there's this idea of circuits. If I've got a lot of circuit elements, what we sometimes solve for is what's called the equivalent resistance. And so what the equivalent resistance is if I took all of the resistors in my circuit and replace them by a single resistor, what would that circuit look like? So replace all resistors by a single resistor. And so with series circuits, this idea of equivalent resistance is actually pretty simple. And so if I'm writing this out, if I have these resistors connected one after another, the equivalent resistance is just going to be the sum of all of the resistors that are connected in series. And so if I'm talking about this, what's called the equivalent, or I'm going to use T for total resistance, is in this case just R1 plus R2. If I had another resistor in there that was connected in series, it'd be R1 plus R2 plus R3, and so forth for however many resistors I've got. And so we can use this to kind of solve for different values in our circuit. So I'm obviously missing some stuff, but if I look at this, RT is equal to R1 plus R2, so my total resistance is just going to be equal to 10 plus 20, which of course you don't even need a calculator, is 30 ohms. So I've got a total resistance of 30 ohms. What that means is I could take this circuit, I've got my voltage source, I could replace this circuit with a single resistor. Now this is still going to be 90 volts. Sorry guys, I don't have my tablet. I'm still going to have the same current going around here. And the resistances equal a single resistor that is 30 ohms. And so that right there makes this a very simple circuit to solve. This is just a direct application of Ohm's law. So I know voltage is equal to I times R. And so let's see where that equation gets us. So my voltage source is equal to my total current times this equivalent total resistance. And so if I'm plugging in values, the voltage of my voltage source is 90 volts. My current, I don't know what that is. I'm going to call that my total current. But I do know what my total resistance is, my equivalent resistance, and that is 30 ohms, and this becomes a very simple equation to solve. So my total current is going to be 90 divided by 30, which in this case is just 3 amps. Now, the wonderful thing is I know that 3 amps is the same for all the resistors. It's the same current going through all of my resistors. And so that's going to let me solve for pretty much everything else in this circuit. So let me just write a few things down so we don't forget it. Our equivalent resistance is 30. Our total current in this case is just 3. Woo, that's messy. Now we can solve for everything else because we know I1 is going to be 3 because this is a series circuit. So the current through all the resistors is the same, and I2 is going to be 3. And again, like I said, that makes it easy to solve for V1 and V2. So, doing one of those real quick, it's actually going to be the same thing for both of them. V1 is equal to, by Ohm's law, my current going through resistor 2 times the resistance of resistor 2. Whoop. What am I doing? Let's make all those subscripts 1. The voltage across resistor 1 is going to be the current going through resistor 1 times the resistance of resistor 1. Well, I don't know what V1 is, but I do know that I1 is the same as I2 is the same as the current coming out of the voltage source. So that's got to be the same for all of my resistors in a series circuit. And I know that's 3. And I know that R1 is 10 ohms. And so I know that V1 is equal to 3 times 10, which in this case is just 30 volts. Obviously, we can do the same thing for V2. So V2 is equal to I2 times R2 equals I2. Got to be the same as the rest of the currents because this is a series circuit. So that's 3 times R2 is 20. So 3 times 20 is 60 volts. And look at that. If I add up the voltage across V1 and the voltage across V2, so 30 plus 60, that's going to add up to the 90 volts of my voltage source. And so I've successfully solved for everything in the circuit. You may have to, solve for things in different orders. There's always, with these circuit problems, depending on how complex they are, more than one way to solve things. You have to kind of go through your circuit and figure out what information you have and what you can solve with that information. So if you look in the next video, we will take a look at a slightly more complicated example.